Okay, now everybody knows pH is equal to negative log of H plus. Okay, and everybody knows pH is equal to negative log of H plus, and everybody knows pOH is equal to negative log of H plus. Okay, in our previous class we have studied up to this. Okay, now how to use them? How to use them in the numericals, that we are going to study now. Numerical solving session of pH scale. Okay, this is the one topic where most of the people having wrong concept. Okay, so let us see first question based upon the pH formula already I have given you. pH formula already I have given you. Okay, now first question, find pH of 10 to the power of -8 molarity NaOH. Question is find pH of 10 to the power of -8 molarity NaOH. Question is about pH. Find pH of 10 to the power of -8 molarity NaOH. Okay. Now, okay, now all of you are aware about the pH and pOH scale. Now let us see how you will be able to solve. Okay, so whoever is solving, just send an answer to me. Send answer to me, then I will verify. Okay, see now, as already I told you, there are a lot of misconcept about this topic, pH and pOH. Okay, so to clear that only I have given this question. 99.99% people answered either 6 or 8. Okay, but it is not the so. It can be something other than this. Okay, only one student got correct answer. Let me see what is the problem with it. Okay, now first of all we have to find out pH. First twist in the question is that we are given with base and we are asked with pH. Okay, that is the first twist. Second thing is concentration from the base is very low. 10 to the power of -8 molarity means the concentration is very much low. In that condition, what you have to do, you should not just rush up to right answer. Okay, and mostly when it comes in the exam, the very first option is 8, and immediately you will start answering 8, very easy. Okay, and you will feel that chemistry is very easy subject, but when you see the marks you will find them in the negative. Okay, so that is the reason. See, NaOH is giving Na plus OH minus. Now sodium hydroxide is a strong base. Sodium hydroxide is a strong base, hence what it will do, it will undergo complete dissociation. So initially it is 10 to the power of -8 0 0. Okay, as yesterday class I told you, dilution depends on 5 factors. Okay, so more diluted means more will be degree of dissociation. That means 100% it will dissociate, and 100% if it is dissociating completely, it will be transferred from here to here. So 10 to the power of -8 and 10 to the power of -8. Okay, now we have concentration of OH minus as 10 to the power of -8. So what you will get, POH is equal to 8. But is it possible for a POH to be 8? No, for base pOH must be less than 7. That means something is wrong. Okay, this is what where most of the students mistakes. Okay, now H2O also gives. Don't forget that H2O is also in the YouTube class already. Previous YouTube class already I told you, the water is a amphoteric substance. Water is a amphoteric substance. Those who attended, those who have seen my previous video, there I clearly mentioned. So regularly keep watching video and be attentive in the class. Okay, so I suggest you people to bring a notebook and maintain a good notes. Okay, so then you will be finding it easy. Okay, so here's H2O also gives H plus plus OH minus. So this will give how much? 10 to the power of minus 7. This is also 10 to the power of minus 7. In previous video I have mentioned this. This is 10 to the power of minus 7. This is also 10 to the power of minus 7. Okay. Now POH we are collecting from the two different places. How many places? Two different places. 10 to the power of minus 8 from base. Okay. And 10 to the power of minus 7 from acid. Sorry, from water we are collecting. That means we are collecting OH minus from how many places? Two different places. Okay. So to maintain accuracy, we should add both of them. Okay. We should add both of them. Now also most of the people will make a mistake. They will write it as a 10 to the power of minus 15. But it is wrong. Okay. So that will be 10 to the power of minus 15 when they are multiplied. Okay, so but here when you are adding them, then we have to take common 10 to the power of minus 7. Okay, then it will be 1.1. On simplification you will get 1.1. Okay, now here this is the OH minus concentration. Now we have to find out what POH. POH will be negative log of 10 to the power of minus 7 into 1.1. Okay, so this will be 7 minus log 1.1. Is it understood? So this is POH, but our question is not POH. We have to be very careful with every word. Question is about pH. Okay, so rest I am writing here. Now pH is equal to what? P 14 minus POH. pH is what? 14 minus POH. pH is equal to 14 minus POH. Okay, so 14 minus 7 minus log 1.1. Okay, so it will be 14 minus 7, that is 7 plus. Okay, log 1.1. So log 1.1 will be somewhere around nearly 0.0 something. That means it is going to be 7.02. How much it is going to be? 7.02. Okay, so that's why this topic I'm specially emphasizing on numerical session, because this type of mistakes cannot be understood. This cannot be explained in the notes, or cannot be explained in any other class. This requires special attention. Okay, so all of you note down this from here to here, and then note down this. Okay, so from here to here, first step. Now the people are started asking doubts. Sir, why we are adding here? Why not every place? Okay, very good doubt. How you will come to know when to add water, when not to add water? That is because here, suppose for example, if it is 10 to the power of minus 3, that time this will be 10 to the power of minus 3. Okay, so 10 to the power of minus 7 and 10 to the power of minus 3, which is greater one? 10 to the power of minus 3 is greater one. How many times greater one? 10,000 times greater one. Once it is 10,000 times greater one, that time you need not to add this one. Okay, in front of 10 to the power of minus 3, it is 10,000 times smaller value. So if even though you do not add, you will get accurate value. But in this question, this is minus 8, this is minus 8. Who is bigger here? This one. So we cannot neglect water OH minus. Is it understood? So note down this question. Okay. Okay. What is the next question? Find pH of 10 to the power of minus 9 molarity H2SO4. Find pH of 10 to the power of minus 9 molarity H2SO4. Find 10 to the power pH of 10 to the power of minus 9 molarity H2SO4. Okay. Okay, some doubts are also coming that I will clear while explaining this one. Okay. So few students started asking doubts if 10 to the power of minus 6 is there, then what we should do. That also we are going to solve it now. Okay. Now you try to solve this question, then I will explain your other doubts. Okay, now listen carefully. This is not, it appears to be just previous question. Okay, but it is not so. It is different in two different ways. How? That time it was base, now it is acid. and that time it was monoacidic base, but here it is dibasic acid. Okay, so every question you will find something new. Okay, so every question you have to be clearly attentive. H2SO4 on dilution 10 to the power minus 9. Okay, so on dissociation it will give 2 moles of H plus SO4 2 minus, 2 moles of H plus SO4 2 minus. Okay, now in this question, see, 10 just like previous initial. Okay, initial will be 10 to the power minus 9, 0 and 0. Okay, and it is going to be final. Final it is 0. See here, be careful. Okay, so every question there is something change. This is the change, 2 into 10 to the power of minus 9. Why? Because it is 2 moles. 1 mole on dissociation will give 2 moles, so 10 to the power of minus 9 will give 2 into 10 to the power of minus 9. Okay, this is 10 to the power of minus 9 only, and we are not interested because we are interested to find out what pH. Okay, so pH is equal to, okay, and of H plus, whenever concentration of H plus is near to, whenever concentration of H plus is near to, like 10 to the power of minus 6 also, it is better to add water, because nowadays in the NDA the accuracy is more and more important. If you don't add, you are getting approximate answer. If you here 10 to the power of minus 6 and 10 to the power of minus 7 also, then what you should do? You should add them for better accuracy. If you don't add also, no problem. Okay, so is that previous doubt, I think it is understood now. Now water also being amphoteric substance, what it will do? It will lose H plus and OH minus both. Okay, so in previous condition we have added OH minus because it was required by the OH minus. Okay, now it is not required. Now what is required here? Here we require about the H plus. Okay, so pure water always contains H plus of 10 to the power of minus 7, and here also 10 to the power of minus 7. Okay, so in both cases we have 10 to the power of minus 7 only, H plus and OH minus. But here we are concentrating. What we are doing here? We are concentrating on, okay, here we are concentrating on H plus because we are concerned with our H plus and H plus given by water. Okay, so at different places what you should do, different thing you should concentrate. Is it understood? So in this place sulfuric acid, previous condition what was the problem? That was the problem with the what? That was the problem of the acid. Okay, now it is, sorry, that was the problem of base, now it is problem of acid. Okay, now when you add both of them, total H plus is equal to 2 into 10 to the power of minus 9, 2 into 10 to the power of minus 9 from acid, and 2 10 to the power of minus 7 from water. Total how much we are getting? We are getting around 10 to the power of minus 7 minus 9. How again we will take common of 10 to the power of minus 7. What we will take common? 10 to the power of minus 7 if we take common. Here 2 into 10 to the power of minus 2 plus 1. Okay. So then it will be 10 to the power of minus 7 into 1.02. 1.02. Okay. So on simplification you can get. Now I will write pH here. Is it understood now? I think everybody is getting what is the logic and when to add H plus, when not to add H plus. What is the difference when there is a acid and base? Okay. When there is a acid and base difference is there, then what you should do, I think now everybody able to understand. Okay. So pH is equal to negative log of, pH is equal to negative log of pH is equal to negative log of 10 to the power of minus 7 into 1.02. Okay, 7 minus log 1.02. So this is going to be something less than. This is going to be what? Something less than 7. Okay, so being an acid, is it understood? From here we got how, what? 10 to the power of minus 7 into 1.02. Okay. And here negative log of 10 to the power of minus 7 into 1.02. 7 minus log 1.02. Okay. So this is going to be something less than. Always acid, it can be anything. It should never get pH less than, more than 7. Acid pH, as pH of any acid, let it be strong, let it be weak, it should be always less than 7, and pH of base must be always more than 7. Okay, so that also we are going to cover on that aspect, so try to note down this. Okay, both condition, I think it is applicable now. Okay, next question is find pH of following mixtures. Okay, so first one, 10 to the power of minus 3 molarity solution of Ha plus 10 to the power of minus 2 molarity solution of H2B. Okay, 10 to the power of minus 3 molarity solution of HN, 10 to the power of minus 2 molarity solution of H2B. Okay, and both of them it is 300 ml. First mixture is, okay, second mixture is 700 ml. Okay, so what you have to do here, you have to look out for the number of H plus also, you have to look out for the concentration also. Okay, and volume also, everything you should understand. Okay, now start sending answers. Okay, now listen carefully. So here both are acid. Water, both. This is also acid, this is also acid. But only the problem is it is monobasic acid and it is dibasic acid. Okay. So this will be M1V1 plus N1. Okay. N2 M2 V2 divided by V1 plus V2. This is, we are going to get concentration of H plus. This is going to be the concentration of, total concentration of H plus. Okay, and when you apply negative log, then you are going to get pH. Is it understood? So negative log of N1 for this, and negative log of basicity of this acid is 1 into molarity is 10 to the power of minus 3, volume is 300. Okay, same way 2 into 10 to the power of minus 2 into 700. Okay, divided by 300 plus 700. So this is the total volume of solution. Okay, this is the total volume. Is it understood? Like this you can calculate the pH. Okay, note down this. Okay, now is this understood? Now let us take another model example. Okay, now next model is, here both are acid. Okay, and now I am taking this as a base. Okay, base is BOH. Second condition is what? This is HA and this is BOH. Then what will be the difference? First we will compare. First what you should do? You should compare the resultant solution is acid or base. First what you will do? You will check whether the resulting solution is acid or base. Okay. For that Na into Va, Nb, Mb, and VB. Okay, so you will compare. Suppose this is more basic, then your answer you are going to get about the POH. If this is more, then the answer you are going to get about the pH. Okay, so like that, here N is 1, M is 10 to the power of minus 3 into 300. Okay, so here it is 10 to the power of minus 2 into 700 into, this is also base it also 1. Okay, so this is going to be 0.03. So sorry, 0.3 I think. Okay, and here it is going to be 2, sorry 7. Okay, so obviously the resultant solution obviously the resultant solution is base, because basic solution, what it is, basic solution, because number of moles of OH minus is more. Okay,